Hey everyone, this video is for those that weren't here today. We're going to go over some exponential functions real world applications. So let's jump right into it. A new museum had 7,500 visitors in its first year. The museum curators expected the number of visitors to grow 5% each year. So I'm going to go ahead and underline that 5% increase, and the initial amount is going to be 7,500. Now it wants us to create a function rule that represents this situation. We are going to use our general formula of y equals a parentheses 1 plus or minus the rate, close parentheses, raised to the t power. Okay, we're going to use this equation over and over again. And what's going to be different every time is the a, whether we're adding or subtracting, and the rate. The x and y are going to stay the same, and they're going to represent different things for each situation. Now, in this situation, let's go jump in. What do x and y represent? Well, x represents the number of years that have passed by, and y is going to be total visitors. Because we know that we start with that 7,500, but every year is going to increase 5%. So let's go back and figure this out. So our a, the initial amount, a is the initial amount, is going to be 7,500. The r is 5%, but we need to change that into a decimal, and that's going to be 0.05. Okay, and then we need to think about, hey, are we going to add or subtract? And the way I think about this is what's going to be in the parentheses. Is it going to be greater than 1 or less than 1? If it's going to be greater than 1, then our situation is increasing. If it's less than 1, we're going to subtract, and that means that our situation is decreasing, or we're going to have decay. And I know that we're growing by 5% each year, so I'm going to go ahead and add because I want my total amount to be greater than 1. Let's see what that all looks like. So y is equal to, instead of a, 7,500, parentheses, 1. I know now I'm going to add because I need that number to be greater than 1. The rate is going to be 0.05, and then I'm raising that all to the x power. My next step is just to clean up what's in the parentheses. So my final function rule is going to look like y equals 7,500, parentheses 1 plus 0.05 is 1.05, close parentheses, raised to the x power. Okay, so now we have our function rule that's going to represent this situation, where I can plug in anything I want for x number of years after 1 year, after 2 years, after 3 years. And that's going to give me my y, which is the total amount of visitors for that particular year. Cool. We took care of A. B, created a table of values for years 0, 1, 2, and 3. Okay, we've done this before, where I am going to plug in different values of x and see what I'm going to get as, let's just do x comma y and let's bring it all together. Okay, so we're going to start with 0 because that's what it calls for. And negative numbers aren't going to make sense because we can't have negative years. These are years after the opening in terms of the museum. So I'm going to plug in 0 for x and see what I get. Y equals 7,500, 1.05 raised to the 0 power. I'm going to type this all into my calculator. 1.7500 times 1.05. And I'm going to raise that. I'm going to use my arrow to the 0 power. And that's going to leave me with my initial amount, because that makes sense, because anything raised to the 0 power is just going to turn that into 1. 1 times 7,500 is 7,500. So our point is going to be 0,7500. Don't get confused that 0 is for the x. My y value is 7,500. Okay, we're going to do this again for 1, 2, and 3. So I'm going to get y equals 7,500, 1.05 to the first power. Y equals 7,500, 1.05 to the second power, because I'm plugging in 2 for x now. And my final one, y equals 7,500, 1.05 to the third power. Cool. Now, a trick I can use so I don't have to retype this over and over again, because the only thing that's changing is just that exponent. I can do second entry, second enter, and that entry, the last entry, is going to pop up. And I'm just going to go back, and I'm going to go back to the 0 and replace it with 1. There's my new number. I'm going to do the same thing. Second enter, replace the 1 with a 2. Enter. Second enter, and replace it with the 3. Cool. So I've got my new amounts for all of my y's. So this is 1,7,875. Yes. 2,8,268.75. And 3,8,682.1875. Okay, a little decimal here, no problem. Okay, so we took care of B. Create a table of values for years 0, 1, 2, and 3. There they all are. Okay, so it makes sense because my y values are going up because it's increasing by that 5% every year. Now I'm bringing up that y values because that's what the letter C is asking for. How are the y values changing year after year? So we want to see what's happening going on from year to year. And remember, we want to use multiplication or division to see what's happening. So what I'm going to do is I'm going to start with this one, 7875, and I'm going to divide it by the one number that came first, 7500. Because I'm dividing it, the opposite would be multiplication. So really, how this is jumping is it's being multiplied by 1.05. And let's just back that up with our calculator. 7500 times 1.05 gets us to our 7875. How are we jumping again? Well, let's see if we're multiplying by that same number, 1.05. So I'm just hit enter. Sorry, multiplying. It's going to take that last answer, and I'm going to multiply that by 1.05. And it's the same answer that we got here, 8268.75. So again, 1.05 is what we're multiplying by. 1.05. Okay, And it's asking, how can you connect this change in y back to the component of your original function rule, where our original function rule, that was our b value. Our b value is how much it's jumping every time, and we just determined that it is, in fact, jumping by the same amount. So our b term here, and remember all this is our b term. We just used the 1 plus or minus and the rate to figure out our b term. Our b term is what the y values are being multiplied by over and over. And that's all I got. Thanks for watching.